Today, we are going to be looking at our tables, equations, and graphs section, and we're going to be talking specifically about the quadratics, right? So what I'm going to do first is we're just going to go through a few big ideas that hopefully you remember, but if you don't, we're going to revise them just so that you can try to remember later. So, first of all, you know that something is quadratic. A specific exponent, though, what? Squared. Because, yes, the highest exponent... What's going on with my pencil? The highest exponent is a 2 or a square. And that comes from the fact that quadratic is a type of quadrilateral. A square is a type of quadrilateral. Now, you can be given that as a function. So y equals x squared plus 2x minus 3, for example. You could also be given y equals x minus 1 times x plus 2. We know that this would be a quadratic because if we multiplied those brackets out, x times x would give us x to the second, or x squared, right? So it can be given to you in different formats. Now, graphically, the graph of a quadratic is a U-shape called a parabola. And it can open up or it can open down. Guys, it will open up if your x squared is a positive. If your x squared is a negative, it's going to open downward. Remember that? Okay? Okay. All right. So those are the basic ideas on how to recognize quadratics. Now, of course, they're going to give you other clues too. They're going to talk about quadratic equation, etc. We'll look at some problems going through these and work them all the way through. Right? Now, we need to talk a little about transitions. So, if you have a shift left or right, what that means is you're either going to add or subtract from x. Right? Remember, x-axis goes right or left? Okay? But remember, when you do that, okay, if it started out here, oh, my pen is going crazy today. Starts out there and goes that way, okay? Let's say that's 4 units. So let's say 4 units left. Remember, when I put that in the bracket with the x, though, I don't say -4. I say what? +4. Remember, putting a number in the bracket with an x changes its sign. Taking it out of the bracket away from the x also changes its sign. Remember that? So what if I wanted 4 units? What's going on with this thing? To the right. Okay? So right on the graph is a positive direction. But when you put it in the bracket, it's going to become a negative. So anytime you put a number in or take a number out, it always changes the sign. Okay? Then, you also can go either up or down. Okay? This affects the constant. Remember, the format is y equals x squared plus x plus, there's some constant at the end. Some number at the end, right? Now, up or down is affected, that one is affected by that one. X squared plus x plus some number, constant. Constant just means a number. Well, just any quadratic always has an x squared and an x in it. Okay? All right. We'll look at plenty of examples. These are just the general notes. Okay. Now, so if I say go shift it up 4, then that would be just plus 4. No sign change because it's not happening to the x part. What if I said down 4? Yeah. That would simply be a minus 4. This thing is making me crazy. All right. No, that's just the constant at the end. Right. Okay? All right. So let's just look at a couple of these and go through some questions, and we'll talk about processes as we go. But these are the big ideas that you need to make sure you remember. Those transitions, those shifts up or down or right or left, and the fact that they're quadratics. Okay? So let's go to some of the problems. Okay? So, guys, on the graph below, sketch the graph of this. Now, remember, a couple of things we need. We need the x-intercepts. And remember, those are simply the numbers in the brackets. Yes? But remember, when you take it out of the brackets, change the sign. Guys, I don't have to do this. All right. So, here, we have x minus 2. So what is that going to do on my x-axis? It's going to be at x.
Positive 2.
X is positive 2, exactly. Let me scoot this up a bit. So x is... I can't see the problem with that. That's not good. So x is positive 2. So you put a dot at positive 2. Okay, good. Then the other one was negative 4. Thank you. Positive 4, which means we're going to put a dot at negative 4. Okay. Right. Now, that tells you where it's going to cross the axis. I need to know whether it's opening up or down. Now, remember, it had that negative in front of the whole thing? What does that tell you? Be careful. Yeah. It's the negative one, so it's going to be down. Don't need anything else because of the original problem. Hold on just one second. Let me answer a question real quickly. So, right? It's negative x squared x minus 2. I'm sorry, x plus 4. Yes, ma'am. Okay.
Doesn't matter how high up it goes. Like
Not when you're just doing a sketch. Not when you're doing a sketch. Now, if you wanted to be more precise, you could find the vertex and plot some other points. But again, it just says sketch. So what they want you to do is find those 2 definite points that you must know and know whether it's going up or down. That's all a sketch does. Okay? Now, again, they used a computer to do theirs, so they found the place. We know where the turning point is going to be because it's always what? We know one value. It's halfway between those values. So this is 1, 2. So it's 1, 2, 3, 4, 5, 6 across, 6 units across. So halfway between that is where it's going to be. Now again, it doesn't matter. You're just going to do a sketch. And if you're sketching with this point and this point, just kind of make sure that it's curving about halfway. Don't make it do this, right? Okay, a nice smooth curve, right? Okay. Now, let's see. That gives us a whopping... Achieve. Wait a minute. They want the maximum. All right. Come on, guys. Let's back up a little bit because they do want the maximum, so they want to know how high it's going. That's not a sketch. That's a drawing. But remember that at the vertex, vertex means the turning point, right? Okay. First, the x value is halfway between the intercepts. So we said this one was at 2, this one was at 4. That's 1, 2, 3, 4, 5, 6 places. So that halfway point, right? So that's at -1. So if x equals -1, simply substitute to find the y value.
Yes, I do remember this.
Yeah. So it's not hard.
Can we have like a full demonstration?
That's what I'm doing now. So we've got our pieces, right? We know that halfway between is -1. Y'all crack me up. Okay? So let's just plug that in and do the work. All right? So going up a little bit. So it's y, because remember, we're looking for our y value. We have our x value already, right? This thing is making me crazy. So y equals the opposite of -1 minus 2 times -1 plus 4. Again, where did I get the -1?
The vertex.
It's halfway. It's halfway between my intercepts, and we know that's the axis of what's it called? Symmetry. Excellent. So simplifying, just leave that out there. -1 and -2 combine to make what? -3. Combining these like terms in there. -1 plus 4 gives you +3.
9.
Minus -3 times +3 is -9. And this negative in front of there is going to turn it into a... So that gives me the point -1, 9 as my vertex.
So we just substitute an x value.
Substitute the x value to find y, right? What if they give you the y value? Substitute the y value to find x, right? If you know one, you can always substitute to find the other. Okay, so they do want it a little more precise. They do want you to find this vertex point, the turning point. Okay? So there you go. Question has 3 parts. Scroll down for parts 2 and 3. Let's see what they ask us. Here we have a parabola. Give the x and y intercepts of the graph above. Remember, the x and y intercepts. What are the x intercepts?
-3.
Well, what does it mean, though?
Where it crosses the x-axis.
Where it crosses the x-axis. It crosses there and there. So that's -3 and +3. Then, it wants us the y-intercept. The y-intercept is where it's crossing the y-axis. That's down here at, what is that? -9. Careful, it's down at the bottom, so it's -9. Okay? So just reading numbers off the graph is all you have to do for that one. Okay? Right? So there you go. Now, one thing we didn't do, remember there's no such thing as a point on the graph without an x and y value, so we were kind of wrong. Our x-intercept's not just +3, it's +3 comma what? 0. And -3 comma what? 0. And our y-intercept is the point 0, -9. Make it a point if you just write the number. Let me show you why. Anytime you're describing points on a graph, you must include both the x and y values.
So you put 9, it could be like 9 into each.
Yeah, so you've got to make sure yes, exactly. You have to tell where it's coming from. Sorry, guys. Give the equation of the graph. So remember, the equation of any parabola is always y equals k times x minus a times x minus b, where a and b are the x-intercepts, right? Okay. So we're just going to plug in what we know. So the first x-intercept, remember we had negative 3, 0, and we had positive 3, 0. So the first one is negative 3. So put in negative 3 here. X minus, I'm sorry, not negative x. X minus negative 3 is going to become what? Positive 3.
Wait, is that like actual positive?
Oh, well, but there was already a negative there. So
How come you made it a negative then?
I didn't. The negative came from here. Yeah, I just dropped it down.
Oh.
Yeah? So all you're doing is plugging in, right? When I put this inside the brackets, it has to change sign, right? But there was already a minus in there. So x minus a. The only thing I'm replacing is the a. And I'm going to replace it with a positive 3, which makes the answer negative 3.
Oh, so if it was positive...
If this had been positive, then it'd be positive 3. Right? Whatever you always change the sign when you put it in. But there was already a negative there. So that negative changed my positive to a negative. Okay? All right. Now let's do the other one. It's x minus b. Okay? So it's x minus, what is my sign now? What is my thing now? Positive 3. So when I move it up here, it's going to become my what? Look, guys, you're going to want to see this. Negative 3. And what happens?
Positive.
There you go.
The two things go.
Negative times another negative becomes a positive. Okay? So we have y equals that. That's it. It's quite straightforward. Okay? So there's your equation. All right, guys, come on, focus. The parabola is moved 1 unit to the right and 2 units up. Okay?
Does that mean it needs a C?
So, yes, it's going to have a C on the end. Okay? If it moves 1 unit to the right, that means that this 3 is going to move to a... Okay? To your other right. Moves to the right. Oh, you were doing the far one. Okay, 4 and negative 2. Guys, so if it moves 1 unit to the right,
then it's negative.
so it's going to be negative 2 and positive 4 now, right? Okay. And that's going to also move to there. But it also said that it moves 1 unit up.
But wasn't it 2?
Or was it 2 units up?
Yeah,
Sorry.
it was 2.
2 units up. So that means the vertex is going to move to there. It's not going to change the intercepts when you move it up, right? It's just going to change the vertex.
So would your new equation be y equals, in brackets, x, take away 2, and then x plus 4, and then
so
plus
y
2 at the end?
Equals, yes. So our new x value there is negative 2. Putting it in there, that turns it into plus 2. It's positive 4. Putting it in turns it into negative 4.
And you need a plus 2.
And since we shifted up 2, we get that plus c at the end. I already took care of that by changing the numbers.
We're just going to get practice paper.
Okay.
To do it at home.
There you go. Then it asks you for the y-intercept. That's the point where it crosses the y-axis. Okay? And all you have to do to find the y-intercept, mathematically, remember, the y-intercept is where x equals what number? Do you remember? 0, because you can't move right or left any. You just plug it into the equation and solve. Okay? Yes?
Why would the x-intercepts change when you move up or down?
It did. Why wouldn't they? It doesn't, because it just crosses the same spot.
But it's going like out.
It just goes up a different rate. It just gets narrower as that goes further up. It's that wide at that point, no matter what. Okay? You're not just taking the whole thing up. It's going to change its shape too. Yeah, when you squeeze up the bottom, it's going to change its shape slightly. At that point. Then it'll eventually do the same thing above.
I thought it would just move the entire thing.
It did. But it has to still go through those points. It can't. No. It did go up. But it still has to go through those x-intercepts. That will never change. It can't go through new. Otherwise, you're making new x-intercepts. It doesn't make any sense. All you did was take your parabola, right? Move it over, right? Then you move the bottom down, up some, right? Which means you're just seeing less of it, but it doesn't change shape. It's still going to go through those pieces. Don't make it harder. Y'all are making it harder than it has to be. You've got x-intercepts. It's going through those x-intercepts, and that's all there is to it.
Wait. But when you bring this entire thing up, is that not?
No.
Does this not come out?
No. It has to go through those intercepts, no matter what. Here, come bring it back, Paige. Let me show you. You're just getting a smaller bit of this. It's moving down, which just means it's just a smaller bit of that, which means this does open up just a tiny bit. But it doesn't matter. It doesn't matter. You've got the intercepts. You just go with the numbers. Yeah. Yeah. It's going to change the shape because you've got less at the bottom, but it still has to spread out that wide, right? If there's less of it and it still has to spread out that wide, it's going to have to be a little fatter. Okay. But it can't. But the shape makes no difference. If you're moving things around, it's going to change the shape slightly. No big deal. But the shape's not the important thing. All right. Giving the intercepts was an achieved. So that's 2 achieved. That's all you need on this question to get it achieved for the paper. But if you gave the equation by just plugging those numbers in the right spot, that's a merit.
I feel like I always get high hopes when you tell me this stuff, and it never ever happens to me in the exam.
Okay. Yeah, it does. Now,
Feels like it. Yeah.
all right, we didn't do the third part yet. All right, give the equation of the parabola in its simplified form in its new position and give the y-intercept. Okay? So remember, the new pieces of the equation. So we have y equals k times x minus a, x minus b, plus c if there is one, right? So y equals, now it didn't turn over, so don't worry about k. X minus, what was our first intercept? A -2. And when you put in minus a -2, what does that become? X minus, what was our other intercept? +4, so just plunk it in. Doesn't worry, the minus was already there. Plus, okay, did we move it up some? How much? Okay. Now we can simplify that by multiplying those out. x squared minus 4x plus 2x plus 8 plus 2.
Isn't it minus 8?
Pardon me? Yes, it is. I'm sorry. Thank you. And gives us negative 2x minus 6. All right? And we know we're right because the minus 6 is our intercept, and that number always represents the intercept, right? Okay? Let's see what we did and what they did and see if we did it right. Because you never know with us. Okay? There's that business. Either aggressive way. No, that's the one we did. That's the 3s. That's what we did. Yeah, it's just going to be if it's opening up down and k is negative. Yeah. There can be a multiplier, but it's odd.
When do we know if it's a multiplier or is that not clear?
We'll look at it. Don't worry about it. No.
Oh yeah. I mean, this is scratching off my dad. So, I think
Yes.
The other equation is that the y equals a, and then it's like x plus b squared plus
I beg your pardon? What?
the other equation that we use is it
The graph of that equation. They're just doing something different. Yeah, we already got the equation. We did the equation. Here's the equation, guys. So we already did the equation. And that, based on that, the interception, we did the equation. We already did this equation. It's x minus 3x plus 3 plus 2. Our new equation is x minus 4. That, I don't know what they are doing. Guys, follow me. That is the equation we got by simply doing the translations, the shifts, and it's the same exact equation. Do not follow all the crap that they went through to get that. And if you write this,
here. It's an excellence. Y equals
excellence.
Wait, can we go show this out? Is this
Yeah.
one of these exams we had to show the working?
Absolutely.
Yeah, and they did it really hard
Okay.
Y equals.
But there's no work to show.
Yeah.
If there's no work to show, you don't have to worry about it.
Okay. Yeah, Mr. Self. Sometimes it feels like I'm fabricating working. Like, you know.
Yeah. You like you're just writing things down so that you can have some working? It's all right. Okay. So that's an excellence question just by reading the numbers off the graph and putting them into that format. That's good stuff. Okay? A is what they're calling K.
the other equation that we use to find the y.
The y-intercept, you can always just replace the x's with zeros. Okay? All right. Look at this parabola. What do you notice about it? Yeah, it's opening down. That means you're going to have a negative in front of your brackets. Remember that? Okay. So, they want you to give the equation of the graph shown below. First of all, 3 pieces of information. The x-intercepts. What are they? -2, Positive 4. That's very important. Okay? The vertex.
Is 1, 9.
Okay? All right. And up or down? Down. Which tells you that the thing in front of your brackets is going to be a negative. Okay? All right. Okay, guys, I'm still losing you. So all we're going to do is take the information we know and plug it in. Shh. Okay? Guys, so y equals k, and then we plugged in our negative 2, which turned it into a positive 2. Plugged in our 4, which just stayed negative 4 because it's x minus. To find the k, you simply substitute the point 0.8, y08, because that's the y-intercept. Yeah. To find k. Substitute the y-intercept into the equation. This is almost a waste of time because it's always, I think at every one of them we did, it was either just a positive 1, meaning it was opening up, or negative 1 if it's opening down, but you need to be prepared. Pardon me?
Is k in place of x or something?
No, remember it's y equals k times x minus a, x minus b. I think when we did it, and in the book, I think they used A here.
Yeah, they did. And they had B and C.
Doesn't matter, right? And then they called those B and C. Doesn't really matter. Okay? So, our y-intercept in this case is right there. That's the point 0.8. Plug that in. Okay? The y value is 8 equals a or k, I don't care, times x value is 0. 0 minus, what was it, 2? And 0 plus 2, I'm sorry. And 0 minus 4. And work it out. 8 equals a times 0 plus 2 is 2. 0 minus 4 is negative 4. And 2 times negative 4 is negative 8. Gives you 8 equals negative 8a. Divide both sides by negative 8 to get the a by itself. And that gives you negative 1 equals a. So our a is negative, which we knew because it was opening down.
Does a also decide how it's
Yeah, something like that. I can't remember exactly. We'll come across it and it'll yeah. Remember, I haven't looked at this since y'all have, so. And it's the first time in my life I've ever seen this work done this way because it's odd.
Is this one of the ones you're like, because you could like find out if that's right by going like, okay, the first one is like 2.
Just find any point. Yeah.
But like, is it one where like you have to do this working just because you have to show you're working? Okay.
Pretty much. Okay? All right. So there's our negative 1, so that just puts a negative in front of our thing. And that correct equation is a merit. Yes. At the end of last year. And I'm only planning to stay here until y'all are gone, and then I'm leaving. I'm just kidding. Yes. That's fine. Okay, next question. This question has 3 parts. Scroll down for the next parts. Sketch the graph of that. Okay? So, first do the x-intercepts, which are easy to find. Okay? Then, plot the vertex. And that's all you need. So, here's my first x. It's just plain old x. That means x plus what?
0.
So that means that word is 0, right? Okay.
On the point, I need a negative 2.
Oh, you just deleted the.
It's all right. I'll rewrite it. I just need to come down a little bit because I can't. We're going to get through this, and then we're going to have the entire end of the period as a break. Entire second period. Okay? Okay. Because I'm not just going to sit here and cram more. That's crazy. But I'll be here in case you have questions. All right. So, to graph, first, plot the x-intercepts. Second, plot the vertex. The x-intercepts are easy. If that's just a plain old x, it has a 0 added to it, which means it's right in the middle. This is x plus 2, so what happens when I pull it away? Negative 2, so that's right there. Halfway between those points is negative 1. Right? So that means y is equal to negative 1 times negative 1 plus 2. All I'm doing is plugging in negative 1 for x, and the reason why is because that's the axis of symmetry, right? So y equals negative 1 times positive 1, which gives you y equals negative 1. So that means my vertex is down here at negative 1. Okay, so it's doing this. And I knew it was opening up. How?
Because it was positive.
Yeah.
Wait, y equals negative 1.
Wait, and when we go up, do we just
Just go up forever.
As long as we hit those.
Just go up forever, and it has to keep getting bigger. Right? Don't do this. Right? It has to be getting bigger, wider as you go up. It's good? Okay. Let's see what that gives us. There it is right there. The purple one. Now don't worry about the red one. That's what they're going to do to it in a minute. Give the coordinates of the x-intercepts. Write the pair of coordinates on separate lines. Well, guys, why am I doing this if y'all aren't going to pay attention? I don't see any reason for me. I could just do my other work that I need to do. The x-intercepts. Well, we already said they happened at 0 and negative 2. So what I have to do, those are my x values. So what are the y values at the x-intercepts? 0 always. Because if it's on that x line, you can't go up or down any, right? Okay? So there they are. That was a question. That was a whole question. Just plugging those 2 zeros in place of the numbers that we already looked at. Yeah, it does. This is a test. Okay?
I'm not sure how that happened.
On the same graph of us, sketch this graph. So x minus 3 tells you that the intercept is what? Positive 3. X minus 1 tells you the intercept is what? Positive 1. Plus 4 tells you that it's been shifted up 4. Okay? Now, the graph looks stupid because it cannot be shifted. Guys, think about it. What were the intercepts? I've forgotten.
Positive 1 and positive 2.
It was
positive 1, and positive 3. If you shift that up 4 units, 1 unit, 2 units, see, we started it down here. So if it goes up 4 units, then what's going to happen is that the vertex is going to turn way up there. So it's still a parabola. It's just way up there. It doesn't touch its own x and y intercepts. But notice that it still needs to line up with those points. So you'll know how wide it was. Does that make sense? If you shift it up 4, it's now way above the x-axis. But those intercepts will still tell you how wide it's gotten. Doesn't really tell you anything about these. It just tells you how wide. No, because you ran out of graph. It's only shorter because there's no you ran out of graph up there. Okay? That's a good question. Super, super simple, but you could easily mess it up.
There's still 21 pages to go.
Okay? Let's see. There we go. We did that. Explain how the graph of y equals x plus 2 is different from the graph of the y of that one. Well, the graph has been translated 3 units to the right and 4 units up. It's right there. But you knew that anyway. Yes. How are these differences shown in the equation? To get the second equation, we added 4 on every x value. Right? That's what right 4 means. Add 4. Yeah? Aw, that sucks. Oh, that's just 1. U for the 1. Both coordinates are correct. That gives you another U. So that's the 2 U's you need for this question to get it achieved.
Lovely.
Okay? Then, if you draw that correct graph for the second one, there's a merit. And then if you describe it, that's an excellent. These are coming from questions. These are from past tests. Let's go to a more current one. Here's a 2016. Let's look at this one. See if it's any different. Maria is investigating a set of rectangles that have an area modeled by negative x squared minus 4x. Okay, so there's your equation. Sketch the graph of the possible ranges of areas of the rectangles as the value of x changes.
See, that confused me because how is the rectangle if you're trying to go like a parabola?
Well, it's going to be a parabola, but remember, what happens with the rectangle is as you change the width, it also changes the height. As you change the height, it also changes the width, so it's never going to be a straight line. And it's modeled by a parabola. Because if you think about area, it's always in square units, so it's going to be a squared equation. All right? No, it's not too hard. Nope. Just think about it. If you think about area is always measured in what kind of units? Square units. Therefore, it's a quadratic equation that models it. Right? Anyway, who cares? Don't even, you know what? You can ignore this part completely and graph that. Right?
Can you please scroll down to
Yes.
Did we go to the zoo question? Yeah, I'd love to go over this.
We can in a minute. Yeah.
Can you scroll down
Okay.
to
So sketch the graph of the possible ranges of the x values. We know it's opening down because it's negative. We have this one, we don't have 2 brackets. So what do I have to do to get my 2 brackets? Factorize it out. Okay, come on, guys. So it's A equals, the negative stays outside. I need 2 brackets. What's common to those 2? X. If you divide out an x, you get x minus 40. So we end up with A equals negative x times x minus 40. All we did was take out the common factor. Now it looks like what we're used to. Which means that the first intercept is what number?
0.
And the second one is what number? positive 40. When you pull it away from an x, it changes the sign. Okay? And we know it's opening down because that's negative. So go down to the graph. We got 0. We got 40. Opening down. Then halfway between that, the axis of symmetry is 20. So plug in x equal 20. Solve to get the y. And that's what gives you the vertex. And those are the three things you need to solve it. It's exactly like the other one. You just have to factor it first to get the two brackets. What's the maximum possible area of the rectangle? Well, the maximum possible area of the rectangle guys, maximum simply means what? The highest point. Minimum means and it's always the vertex, the y value of the vertex. So how high does this go? 400. So the maximum area is 400. Okay. For what values of x are these areas less than 300? Okay. Well, you simply put in the area of 300 and then equals the equation and then solve it. And it'll give you your two values. Now, I'm thinking you could also solve this graphically without having to use math. Look, if you want it to be below 300, here's 300. Where does it intersect there? Where does it intersect there? And that's perfectly acceptable as long as you show where you got them on the graph. The whole point behind drawing a picture of the graph is to be able to easily get information from it, right? Okay? All right. So what if I wanted all the possible values less than 100? Here's.
You would draw a line at 100 and then look at where the y is.
That's a little harder to read, but no big deal. Okay? That's all you have to do. All righty. Now look at what they did. Okay? Now you do have to give a range of values because it said less than. So it's anything between those 2 points and those 2 points.
What is that?
That looks really, really
Hold on.
Oh, I figured, oh my God.
Excuse me.
Oh, no.
All they're doing is taking this bit, factoring it, and solving. Let me show you the work. There it is. So you just solve it for x. Okay? Solving it for x just means get the x by itself. So if it's x squared, dang this pen, x squared minus mx. They both have an x in them, so factor that out. Okay? Then, oops, sorry. Okay? Yeah. Okay? Then, x equals 0. M minus x equals 0. Subtract m from both sides. It's going to just give you x equals m. Hold on a minute. Okay, the zoo problem. They're talking about wanting to maximize the size of the pen, right? Maximize the size of the pen given that they only can use 600 meters maximum of fence. Does that make sense? So if you think about what that means on a graph, that means they can use no fence or 600 meters of fence.
Is this a Zoom question?
Pardon? This was off of from an old exam. Okay? So if this is 100, 200, 300, 400, 500, 600. So there we go. Right? So we can use anywhere from 0 to 600 meters of fencing. Right? And I want to find the maximum area I can get for that. Yeah? So, this is x, this is x, this is x, and they say this side is 600 minus 3x.